Okay, so on your quiz tomorrow, guys, you're going to have 8 questions. Write this down so you can see it. I'll write it down so it's right in front of you guys. You're going to have on your quiz 8 questions total. All right? From those 8 questions, there's going to be 4 that say solve by factoring, which is what we did a bunch of yesterday. You guys have done factoring since we started this class. You're going to have 2 that you're solving that involve square roots. And you're going to have 2 that are solving involving rationals or fractions. All right. What we have to remember is when you're solving the square root ones and the rational ones, you have to check for extraneous solutions. What does that mean?
What does that say?
Answers that aren't real.
Answers that don't work. Rationals or fractions. Extraneous solutions are answers, we'll say, that don't work. When you plug it back in, it does not make the equation true. You don't have to tell me, oh, these are extraneous. You just have to cross them out. You have to somehow make me understand that you guys know, ooh, this one's not a solution to this equation. Does that make sense? Everybody understand that? Check for extraneous solutions. They're extra. They're ones that don't work. Okay, very important that you guys do that. You don't have to show me the check. You don't have to write down a formal check. But you need to do something to where you go through and say, oh, okay, this solution, this x value either makes the denominator 0 or it makes the radical negative or something like that, to where the answers are not true. Okay, everybody understand?
Is that only for the ones that we're doing right now?
Correct.
And then for the square root.
So this first square root one, everybody see the one I'm talking about? When we work with square roots, guys, the first thing I told you to do was to isolate the square root. Circle the square root because you want to get it by itself. Sometimes there's stuff being added and multiplied and all that, so you need to make sure your eyes see what needs to be by itself. So how do I get this radical completely alone? What do I have to do? That says square root of 3m plus 2. Lewis, tell me. I'm going to add 5. I'm going to move that 5 to the other side. That says minus 5, so I'm going to add 5 to the other side. So this becomes the square root of 3m plus 2 equals 5. Does everybody understand that? Is the radical by itself now? Yes, so now we can just solve like normal. How do you get a square root to go away? What's the opposite of taking the square root? You square it. Good. So if we square one side of the equation, then we do what? You square the other side. So this becomes 3m plus 2 equals, what's 5 squared? 25. Perfect. Now what? Subtract the 2 from both sides. And I get 3m equals 23. And now what? Divide both sides by 3. God bless you. And you get m equals 23 over 3. Is it okay to get a fraction? Yes. Now, you have to check, guys, because you got to make sure that it satisfies the equation. So I have my equation of 3m plus 2. And then this minus 5 is on the outside equals 0. When I say satisfies the equation, it means when you plug it back in, it makes the equation true. So even though it's a fraction, it's really not that big of a deal because you have 3 times 23 over 3 plus 2. The minus 5 is on the outside. Does that equal 0? When you multiply 3 times 23 over 3, what happens to these 3's? They cancel. So you have the square root of 23 plus 2 minus 5 equals 0. Right now, you guys can tell me yes or no. What's 23 plus 2? 25. What's the square root of 25? And what's 5 minus 5? So you know right there, that's good to go. You don't have to show me the formal check. You don't have to show me that. But you should do it somehow, a little bit in your brain, on paper, just a little bit, so you can make sure that your answer works. Does that make sense? The main thing with square root equations is you have to isolate the square root first. You have to get it by itself. Let's move on to this one. All right. First thing we should do is what? Nope, not yet. First thing first. I agree with you, Tommy. But what's the first thing we should do when we see a square root? Circle it. Yes, sir.
We don't circle the negative with it?
No. Good question. Good question. You don't circle the negative with it. Very good question. So if I move the 3, I'm going to subtract 3, right? Because it's a positive, so to get it to the other side becomes negative. Okay, so I have negative square root of x minus 3 equals x minus 3. Now circle your square root again. I'm so glad you said that. How do I get that negative? What number's in front of there? It's a -1. How do I get that -1 to go away? I'm going to divide both sides by -1. When you divide, guys, both sides by -1, what does it do to the signs on the other side? It just changes them. You have x divided by -1 is -x. -3 divided by -1 gives me +3. Good. Is my radical by itself now? Yes. Now, how do you get rid of a square root? What's the opposite of a square root? You square. So if I square this side, then I have to square this whole side. Agreed? So this cancels out. I have x minus 3. Now, somebody asked me last period, how come you don't just distribute like we did before? The reason why you don't is because before we distributed when everything was being multiplied. But do you see that plus sign in the middle? You can't just distribute over a plus sign. So what this means is negative x plus 3 quantity squared. It means I have negative x plus 3 how many times? Twice. So we FOIL. So negative x times negative x is x squared. Negative x times 3 is negative 3x. Positive 3 times negative x is negative 3x. Positive 3 times positive 3 is 9. So I have x squared minus 6x plus 9. That's going to go right here. X squared minus 6x plus 9. And now we go back, guys, to basic algebra. If I'm going to solve this, this is a quadratic, right? Because I have an x squared and I have an x. So how do I solve this? What needs to happen? Move everything where? To one side. You can move it to the right or left. It doesn't matter. I'm going to move it to the right because I always like to keep x squared positive. So I'm going to subtract x from both sides, and I'm going to add 3. Do you guys see why I put x under the x and I put the 3 underneath the constant? Okay, so those cancel out. We have x squared minus 7x plus 12. Does this look like something we have seen before? Yes. Are there factors of positive 12 that multiply to give me positive 12, but add to give me a negative 7? X minus 4 and x minus 3. So my two x values are x equals 4 and x equals 3. Question?
Why would you, how did you,
This is where you guys have to be super careful, right? You did a great job with your algebra and all that stuff, and you got 2 answers. But since we have a square root problem, what do we need to do? We need to check. So I'm going to rewrite my problem right here.
wouldn't it be 6, not 12?
So when I rewrite my problem, my original problem was, read it to me, 3 minus the square root of what? X minus 3 equals x, right? That was my original problem. You guys with me? So we're just going to check and see, just to see if we're right or not. We came out with x equals 4 and x equals 3. If you just circle them both and go on to the next one, you may get points off because they may not both work. So if I plug in 4 everywhere I see an x, I have 3 minus the square root of 4 minus 3. Does that equal 4? Well, 3 minus, what is 4 minus 3? What's 4 minus 3? 1, okay. What is the square root of 1? 1. 3 minus 1 is what? 2. Does 2 equal 4? No. So is x minus 4, is that a solution? Does it work? No, it does not work. So you need to go where you have your solutions and cross it out. yes, it worked out algebraically when you did your problem, but when you plug it back in, if it does not work, does 2 ever equal 4? No. So that's not a solution. You don't have to tell me it's extraneous or anything. Just cross it out. Make sure I understand you know that doesn't work. Yes. So now let's try 3. So if I have 3 minus the square root of 3 minus 3, does that equal 3? Okay, well 3 minus, what's 3 minus 3? 0. What's the square root of 0? Guys, what's the square root of 0? 0. So 3 minus 0 is 3. Does 3 equal 3? Yes. So this is a solution. So how many solutions are there for this problem? Just one. What would your answer be if you plugged it back in and neither of them worked? None. No solution. That's a possibility. That could happen. So you might get 2 solutions and think, oh, yes, I'm awesome. And which you are. You guys are all awesome. But you have to go back and check just to make sure that they work. Understand? Okay, there's a lot going on in this problem. That's why I want to do this one. What did I tell you to do first when you see a square root? Circle it. Thank you, ma'am. Circle it. So I have to get rid of that minus 8, and I have to get rid of times 3. What would I do first? I'm going to add 8 to both sides. Good. So I have 3 times 3x minus 5 equals what? 12. Circle your square root again, because you got to get it all by itself. Make sure you can see. Is it completely alone? No. So what do I have to do? Divide both sides by 3. Good. So I have the square root of 3x minus 5 equals, what's 12 divided by 3? 4. Is my square root all by itself now? Yes. So then how do you get rid of a square root? You square it. What you do to one side, you do where? To the other. So I have 3x minus 5 equals, what is 4 squared? 16. Can everybody in here solve this problem? Absolutely. What do you do to get x all by itself? You add 5. Awesome. So I have 3x equals, what's 16 and 5? 21. Awesome. Divide both sides by 3, and x equals how much?
7.
X equals 7. Now, great job, but what should we do before we move on to the next problem? Let's just check it real quick, right? Take your original, 3 square root of 3x minus 5 minus 8. Does that equal 4 when you plug in 7? So I have 3 times 7 minus 5 minus 8 equals 4. Again, you guys don't have to show me this step. You can do this in your head if you want to. What is 3 times 7? 21. What's 21 minus 5? What's 21 minus 5? 16. What's the square root of 16? 4. What's 4 times 3?
12.
What's 12 minus 8?
4.
Does 4 equal 4?
Yes.
You're good to go. You can do it like that. You can work it all out if you want. 3 times, you have 21 minus 5, then minus 8 equals 4. 3 times the square root of 16 minus 5 equals 4. Square root of 16 is 4, so 3 times 4 minus 5, does that equal 4? 12, that's an 8, whoops, sorry, I can't read my own writing. 12 minus 8 equals 4, yes, 4 equals 4. But you have to make sure you plug back in just to make sure, yes, it works, or no, it doesn't. Questions? Does anyone have any questions? What happens if you plug your answer back in and you get a negative underneath the square root? No solution. Make sure you see that. If you get a negative underneath the square root, say, uh-oh, nope, no solution. We can't have that.
Even underneath as in the denominator or like...
No, underneath the square root means like right there. Underneath the square root. That would be no solution. All right, so when we're talking about square roots, guys, the first thing you have to do is isolate the square root, circle it. Anything that's being added, subtracted, multiplied, divided, get it to the other side. And then just solve like you would a basic problem. To get a square root to go away, you have to square it. And then plug it back in to make sure it makes the equation true. We okay? All right, you will have two of those square root ones, and then you're going to have two rational ones. Rationals mean fractions. When you have fractions, guys, you need to have a common what? Got to get a common denominator. So let's look at 24. First of all, what is the denominator underneath the whole number 3? 1, right? So each denominator here is different. There's an x minus 1, and a 1. So if you're going to get a common denominator, just take each one of them. You have x minus 1, and you have a 1. This is the same concept if you had 1/2 plus 1/3. Would you guys agree with me that you would take the 2 and you would take the 3, right? Yes or no? Right? Yes, we can multiply them and they become 6, but you're still taking one of them and the other one and just multiplying them together. Same concept. So now you just look at each fraction individually. Look at this first one. This denominator has an x. What is it missing from the blue? It's missing the x minus 1. So if you put the x minus 1 on the bottom, you have to multiply it where? To the top. X minus 1. Good. Now let's look. The second fraction, it has the x minus 1. What is it missing? Just the plain old x. So if you multiply the bottom by x, you multiply where? The top by x. Good. Now you look at the last thing. It has the 1. What are the two pieces that it's missing? X and the x minus 1. So what you do to the bottom, God bless you, you do where? To the top. Now, do you guys see how all three of these denominators, do you see how now all three of these denominators are the same? Yes? Yes or no? Okay, once you have all three denominators the same, you can just cross off the denominators. You can just go just like this. It's gone. And now we're just going to solve the top. It's just a normal equation that you guys have done a million times. You have to find what the common denominator is going to meet. Make them all equivalent, and then that denominator is gone. You just solve the basic equation. So in the numerator, I have 1 times x is x. 1 times negative 1 is minus 1. What is this sign right here? It's a plus. If it were a negative, you guys got to be careful. You're not going to have to distribute a negative, but it's plus, so you just have plus. What's 2 times x? 2x equals 3x. What do I do with this 3x? So it's 3x squared minus 3x. Okay. Do we know how to solve this kind of an equation? Yes or no?
Why would it just be minus 3?
So 3 times x is 3x. Then you have x minus 1. So when you distribute, this becomes 3x squared minus 3x. See that? So now what? If we have a quadratic, we need to move everything where? To one side. Can I simplify anything over here?
Yeah.
Yes. So I have 1x and 3x. 1x and 2x gives me. So I have 3x minus 1 on this side. And over here I have my 3x squared minus 3x. So I'm going to subtract 3x from both sides. And I'm going to add 1. Do you guys agree with me? So I have 3x squared minus 6x plus 1 equals what? 0. Where? Well, if I have 1, I have 1x here and 2x here. It's already positive, so to get it to move over, it's going to become negative.
I was thinking you did it for the...
No, you're fine. Now, from this point, guys, how would we solve this? You'd have to use the quadratic formula. I'm not going to go through doing this. I'm not going to give you guys a rational with the quadratic formula. This is the main part. Understanding how to get a common denominator. That's why I wanted to do this one, because this is very basic with just an x and just an x minus 1. On your quiz, it's going to work nicely, I promise, just like this one. I just wanted to do that one at first to try and get your guys' minds working to how to get a common denominator. Do you guys see this problem as 3 separate fractions? Yes? Okay, so look at each denominator, and we first have to see if any of them factor. So x minus 2, does that simplify to anything? Can I factor that at all? No. X plus 2, can I factor that at all? No. X squared minus 4, can I factor that at all? Yes, what does that become? X minus 2 and x plus 2. Good. So what is my common denominator? For all 3 of these fractions, what would a common denominator be? X plus 2 and what? X minus 2. Okay, so let's do this. Let's work through this together. You guys are doing a really good job, and then we're going to solve, and you're going to feel a little bit better. This first fraction right here has the x minus 2. What is it missing? So if you multiply the bottom by x plus 2, then you multiply the top by what? X plus 2. This second fraction has the x plus 2. What is it missing? So if I multiply the bottom by x minus 2, I multiply the top by x minus 2. Agreed? The third fraction, it already has x plus 2 and x minus 2. Do I have to multiply the numerator by anything? No. So have we created equivalent fractions? Do all 3 of them now have the same denominator? Yes. So what can I do to all those denominators? Cross them off. So I'm left with x times x plus 2 plus 1 times x minus 2 equals 8. Does everybody see that? Once you get them to be equivalent, just cross the denominators off. You don't need them anymore. And then you just solve like you would a regular quadratic. Solve this. Whoops. My pen's a little too thick there. So x times x is x squared. X times 2 is plus 2x, right? Plus, well, 1 times x is x. 1 times negative 2 is negative 2 equals 8. Agreed? Can I combine anything? Okay, x squared plus 3x minus 2 equals 8. How do I solve this, everybody? Come on.
Grouping.
Not grouping. Is everything set equal to 0? How do I get it? I'm going to move the 8, so minus 8. So I have x squared plus 3x minus 10 equals 0. Is this something we have seen 150,000 times? What are the factors of negative 10 that multiply to give me negative 10 but add to give me 3? Perfect. X plus 5, x minus 2. Good job, guys. So what are my 2x values? Negative 5 and positive 2. Can I just congratulate myself and pat myself on the back and move on to the next question? I have to check to make sure that the denominator does not become what value? 0. If I plug in negative 5 right here, negative 5 minus 2, is that going to make it 0? What's negative 5 minus 2, guys? Negative 7. Okay, that's not 0. If I plug in the next one, negative 5 plus 2, is that 0? No. If I plug it in the last denominator, negative 5 squared minus 4, is that going to give me 0? No. So negative 5 is a good solution. What happens when I plug in 2? What's 2 minus 2? 0. Are you ever allowed to have a denominator of 0? So right now you can go, that one doesn't work. But you have to tell me, yes, this one works. No, this one doesn't. Yes, both of them work. Awesome. What would happen if you plugged both of them in and they both made your denominator 0? Your answer would be no solution. If you ever check and you plug it back in and it makes your denominator 0, or if it's a square root, it makes your equation untrue, then your answer is no solution if none of them work. All right, let's look at this last one. All right, this is the easiest of the rationals. You'll have one of these, but you'll have one of these. This is just a proportion, guys. When you have a fraction equal to a fraction, we talked about this before. When you have a fraction equal to a fraction. Anybody remember how to solve it? You cross multiply. Good. You cross multiply and solve. So if I cross multiply here, I have x times x plus 6. You guys see that? Now we have equals. Cross multiply here, I have 3 times 9. You guys with me? So x times x is x squared. X times 6 is 6x equals, what is 3 times 9? 27.
We can't simplify?
Hmm?
We can't simplify 3 and 9?
No, because you're multiplying here to solve the equation. If you make it 1, it was 3 over x plus 6. Look, Tommy, if it was 3 over x plus 6 times x over 9, yes, you could simplify there. But since there's an equal sign there, you can't simplify. Would you guys know how to solve something like this?
Yeah.
What would we do with 27? We move it over to the other side. I'm going to subtract it. So if I subtract 27, I have x squared plus 6x minus 27 equals 0. Are there factors of negative 27 that multiply to give me negative 27 but add to give me 6?
Yeah.
What are they? X plus 9, x minus 3. So x equals negative 9 and x equals positive 3. Agreed? Okay, go back. If I plug in negative 9 to my denominator, will it be 0? Ladies and gentlemen, if I plug in negative 9 to the denominator, x plus 6, will it be 0? No. What about if I plug in 3? Okay. All right, this problem I made up just to make sure that we understood how to find answers when you're cross multiplying, right? Super important that we understand when you have a fraction equals to a fraction, just cross multiply. Everybody with me? All right, so you guys should be ready for your quiz tomorrow. If you look at this problem, I know we just, whoops, hold on, I told you the beauty of these problems is you can always check. So in our original, and this is why I just checked the denominators, but you can check the whole thing. In my original, right, I have this. I got x equals negative 9, and I got x equals 3, correct? So if we plug in negative 9, we have 3 over negative 9 plus 6 equals negative 9 over 9, right? So I have 3 over negative 3 equals negative 9 over 9. What is 3 divided by negative 3? Negative 1 equals, what's negative 9 divided by 9? Negative 1. Does negative 1 equal negative 1? Yes. So plug in 3. 3 over 3 plus 6 equals 3 over 9. Well, 3 over 9, does that equal 3 over 9? Yes. So this one works as well. You can plug it in the whole thing. I'm just saying